Hi, welcome to our NLP class. Today is part 9, and we are going to see the history of probability and how this probability theory is being used in machine learning and NLP model usage in NLP and machine learning. So, when we look at the history of probability, it started around the 6th century. In 6th century, we found that the Arab mathematicians they were using this probability theory mainly for communication purpose. When they need to send information from one place to another place secretly, they were using this probability theory to decode and encode the message. And also they were using this probability theory in inferential statistics. That means when the data is given, how to infer the information from the data. So then it is going on from 6th century to 8th century, and only in 16th century there were a big development in probability theory. This is happening in Europe. European mathematicians, they were developing this probability theory mainly for in games, in gambling industry. So they are very much interested. This is where a lot of uncertainty is there. So we cannot find out the answer as the mathematical derivation and expressions can only work whenever there is a certain that certainty in that incident or the experiment. Here in gambling industry, lot of uncertainty. So they were developing some um, kind of methodology to find out the chances of winning a game, chances in the game. And in the 16th century there were two mathematicians. They were actually focusing on developing methodology for games. One is Pierre de Fermat, and another mathematician is Blaise Pascal. So the first mathematician, Fermat, he was focusing on just coming up with some kind of qualitative methodology to see what is the chances of winning in a game for a player. Chances of winning in a game for a player, given player. For example, if there are two players, A and B, so if there are two games, there might be different combinations. One is A is winning in the first game, second time also A is winning, and in another combination would be A is winning in first game but B is winning in second game, and B wins in first game, A wins in second game, and B wins in first game. So by there are different combinations, and Fermat was using this information, coming up with the methodology to predict that what is the chances of winning for A and chances of winning for B. This is a kind of a qualitative answer, but Pascal was devising some kind of quantitative methodology, how we can compute the expected outcome of this experiment, expected value of winning for A and expected value of winning for B. And so mainly it was used in gaming industry. Then we found that during 18th century they found another application of this probability theory. So can you guess where it is? Which is in insurance companies. Do you wonder how come they use this probability theory in insurance? Yes, that in 18th century, exactly in year 1762, One insurance company, they used the customers, their policyholders data. They just gathered all the policyholders data, and then they collected that mortality rate. So during those days, the mortality information were available everywhere in the country, and in Europe they actually collected this mortality rate information, and they came up with that technique to price their policyholders using this evidence. So it was not actually that transparent to the policyholders, but later on it was found that the company was using this data to come up with that insurance policy price, so that they can make money from that insurance. And then yeah, so next we will see what happened in 19th century. In 19th century there is an interesting theory that the famous mathematician Laplace and his fellow mathematicians, they were actually developed a technique for applying this probability theory in judicial system for social justice. You know what is going on in judicial system? So there would be a judge hearing the case, and here is the convicted person. So convicted person, yeah, the judge would be hearing the story from the convicted person, and he doesn't know that whether he is innocent or guilty. So based on the information that all the information provided to him, he would just judge the person is either guilty or not guilty. Here there are the the chances for guilty may not be 100% true. There are some cases the innocent may get caught as a guilty. So in order to avoid the situation, there is always a probability of innocent person being caught as a guilty, or that really uh, uh, person who convicted and made the crime could be escaped as a no guilty. So in order to avoid the situation, this is a very serious problem, that punishing an innocent person. Laplace came up with that idea that instead of just using one judge, that he actually came up with that methodology to identify that number of optimal number of jury. It's a kind of jury system, that there would be multiple n number of jury 1, jury 2, jury 3, 4, 5, 6, 7, 8, 9. Yeah, so now that not only this judges would be actually saying that the person is convicted, person is guilty or no guilty. Each jury should analyze the case individually without communicating. They need to be separated out. They cannot communicate with each other. So, an individual person needs to say, based on the evidence, whether he is a guilty or no guilty. Guilty, he is saying no guilty, guilty, no guilty, no guilty, no guilty. So, we would see there are X number says no guilty and Y number says guilty. So, then he devised a model to predict that at least how many optimum number of jury needs to say he is guilty. If the y is greater than or something, some threshold value, then finally the person can be convicted as guilty. Otherwise, if there are no strong evidence, then needs to be no guilty. So this was very useful for the society. So he devised this methodology in 19th century, and so up to this time, what was happening is mostly that probability theory, where you mainly focusing on descriptive statistics, just looking at that name that integers, and that devising a model to just count something, and what is the chances of these many uh, that winning could happen in an experiment or something like this. But yeah, so From this probability theory in 19th century, there are a lot of statistical techniques were developed. So a lot of informations were collected, and by looking at that all these data, and then they were trying to infer something from this data. They came up with the kind of descriptive statistics to describe the data, just like simple mean, median, standard deviation, and they have come up with a lot of hypothesis testing. Lot of statistical techniques were developed. Then, in only in 20th century, there was a big tremendous improvement in the application of the probability theory in continuous space. So, how we can build a probabilistic model using real values, not only integers, using real values and predict something. Then in 20th century, the big contribution was actually um, by the Bayesian. Bayesian theorem was the one actually that contributed a lot in using this probability theory and machine learning. And now we see that how this Bayesian theory or any other probability theory is being used in uh, NLP models. So before we understand how this probability, that Bayesian concept is used in NLP, so what is the main goal in NLP? NLP, we want to have a model. So in probability theory, we want to have a probabilistic model and then find out, predict something. So in our sentiment analysis problem, it is finding out whether the sentiment is a positive sentiment or negative sentiment. So here there is a sentiment and here there is another sentiment. We want to find out whether the sentiment is a positive sentiment or negative sentiment sentence. How do we do this? Here we want to have our probabilistic model, and then the input would be the data corpus. There are some probabilistic model. The input vector necessary to find out this mapping function or find out the answer for the mapping function is some kind of probabilistic value. What is the probability for being the sentiment as positive? What is the probability for being the sentence as a negative? And what is the probability of sentence, this sentence is positive with the sentence has the word good or bad something. So these are the probability values we need to know in order to come up with the probabilistic model. So before going into the details of how we compute these probability numbers, we will see what is the main concept or formulas in probability. Just to how we compute the probabilistic score. So we see that, for an example, let us so take a classical example, tossing a coin. In tossing a coin, that one person would be conducting experiment, just tossing a coin multiple times. Maybe first time it may end up as a head, a second time it might be tail, head, head, tail, tail. We do not know. So when after conducting this complete experiments, when we take the outcome of each experiment and see, out of total, if there are 100 experiments conducted, then out of 100 experiments, how many times we end up with um, head and how many times we end up with tail. Look at it, might be closer to 0.5. So when the number is 100, it would be maybe around it would be 50, 56, another could be it's 44. So when we increase the number of experiments, it would be very closer to this 0.5. So when we do multiple times, that million times, we may end up with the head as being as 5000000 something, and tail would be 4.999 and something. Oh, it's not 5 point, it should be zero point 0.5. Head should be 0.5000 something, and tail would be 0.4999 something. So this is how we actually conduct experiment and calculate the probability. But when we were given with the evidence that this data, so in our NLP model, what we have is it's a corpus. Corpus has lot of sentences. Maybe let us assume there are 10 sentences or 10 movie reviews. We'll see 10 movie reviews. 1, 2, 3, 4, 5, and another 5 movie review. 2, 3, 4, and 5. Yeah. So and then let us consider an example that we want to compute probability of the sentence is a positive sentence, and probability of the sentence is a movie review is a negative review or negative sentiment. How do we know this? Here, instead of doing the experiment, we look at this data and see, let us assume that we have a balanced sample. There are actually 5 positive sentiments. These are all positive sentiments, and here we have negative sentiments. There are 5 negative sentiments. So in total there were in total, when we calculate the probability, the denominator is total number of the movie reviews 10. That positive, how many positive reviews we have? 5. We end up with having probability of the sentence being positive is 5. Similarly, we calculate the probability of the sentence being negative. The total number of sentence remains same, 5, and here the total number of negative reviews are 5. Then this is 0.5. So these are the uh, basic probability calculation. Similarly, we can do the conditional probability. We can compute the conditional probability, like what is the probability of the sentence being positive given the sentence has the word awesome. Another example could be, what is the probability of the sentence is negative given that the sentence has the same word awesome. And by computing these values, we can compute what is the probability of the sentence or movie review is positive given the sentence has value awesome and some other words, maybe good, liked, movie, and what is the probability of the sentence is the positive sentence or positive sentiment. So we will see how we can apply this Bayesian formula and then come up with the Bayesian classifier. Earlier we saw that how we can apply logistic regression for NLP model. Here next class we will see how we can use this Bayesian formula and how we can come up with that naive Bayes classifier for this NLP model, sentiment analysis. So in this process, that only the difference is the probability model. So we need to compute some probabilistic values that are necessary to compute the Bayes formula, and that mapping function would be same, and we will have our final prediction using our Bayesian classifier. We will see this concept in our next class. Thank you. Bye.